This video explains continuity on an open interval, continuity on a closed interval, and intermediate value theorem. What is continuity on an open interval a and b? A function f of x is continuous on an open interval a, b if there is no point c in the open interval ab where f of x is discontinuous. What we're saying here is the f of x is continuous on an open interval ab if f of x is continuous at every point in the interval a and b excluding a and b. A function f of x is discontinuous on the open interval a, b if there is a point c in the open interval a, b where f of x is not continuous. So if there is any point in the interval where function is not continuous, then we say f of x is discontinuous on the open interval. Continuity on a closed interval ab. If function f of x is continuous on a closed interval a, b, if f of x is continuous on the open interval a and b, and f of x is continuous from the right at x equal to a, that is limit of f of x as x approaches a from the right is equal to function value evaluated at a, and f of x is continuous from the left at xb at x equal to b, that is the limit of f of x as x approaches b from the left is equal to f of b. The intermediate value theorem. If f of x is continuous on closed interval ab and k is between f of a and fb, then there is at least one number c in a and b such that f of c is equal to k. So look at this graph. The k is a number between f of a and fb, and there are three numbers c1, c2, c3 where the function value is equal to k. Example 1. Use of intermediate value theorem. Verify that the intermediate value theorem applies to the indicated interval and find the value of c guaranteed by the theorem. So we have a function f of x equal to x squared plus x minus 1, and the interval is 0, 4, and function value evaluated at c is 5. So first we check if f of x is continuous on the interval 0 and 4. Well, f of x is a polynomial function. It's a quadratic function, and the quadratic functions are polynomial functions. And polynomial functions are continuous on the entire number line. Therefore, f of x is continuous on 0, 4 because this is being a part of a number line. Second, we find f of 0 and f of 4 using this function. So f of 0 is 0 squared plus 0 minus 1 equal to minus 1. Then find f of 4 to be 4 squared plus 4 minus 1 equals to 16 plus 4 minus 1, 19. Now we check if given 5 is between -1 and 19. So you can see the 5 is between -1 and 19. Therefore, f of c is between f of 0 and f of 4. All the conditions of intermediate value theorem have been satisfied, so we can say as intermediate value theorem applies. So now we set f of x equal to x squared plus x minus 1 equal to 5. So the equation becomes x squared plus x minus 1 equals to 5. Now this looks like a quadratic equation, so we move 5 to the left side. So it becomes x squared plus x minus 1 minus 5 equal to 0. We're simplifying it x squared plus x minus 6 equal to 0. And we can factor into x plus 3 minus x minus 2 equal to 0. Set each factor to 0, x plus 3 equal to 0, and x minus 2 equal to 0. Solve for x. It gives you x equal to -3 and x equal to 2. -4 is not in the interval, so ignore. 2 is inside the interval 0, 5, so c is 2. Application of intermediate value theorem. If f is continuous on a closed interval a and b, and f of a and f of b have opposite signs, then by intermediate value theorem there is either 1, 0 or more than 1, 0 in the interval a and b. Or you can say there is at least 1, 0 in the interval a, comma. So example 2, existence of a 0. Explain why the function has at least 1, 0 in the given interval. F of x equal to x cubed plus 4x minus 5. The interval is 0, comma 2. Well, you can say f of x is a polynomial, so it's continuous on the entire number line. So therefore, it's also continuous on the interval. Now let's find f of 0 and f of 2 using this function f of x equal to x cubed plus 4x minus 5. F of 0 equals 0 cubed plus 4 times 0 minus 5. So simplifies to negative 5. Now find f of 2. 2 cubed plus 4 times 2 minus 5. 8 plus 8 minus 5, 11. Now f of 0 is negative 5 less than 0 and f of 2 is 11 greater than 0. You can see f of 0 and f of 2 have opposite signs or alternate signs. Therefore, by the intermediate value theorem, f of x has at least 1, 0 in the interval 0 to 2.